Hi, I'm Kathy Levinger. In this section, we're going to solve linear equations in one variable. Let's start with the following. What we want to do here is determine whether a given value of the variable is a solution to the linear equation. Well, there's a lot of information here that I'd like to point out so that you understand some of the terms that we're using. The given value of the variable is this number, -1. Actually, the variable is t, which you see on both sides of this equation. This is actually what's called a linear equation. We see the variable t raised to the first power only in the equation. To determine whether -1 is a solution to the linear equation, we want to see whether when it is substituted in, the right-hand side gives us the same value as the left-hand side. So let's start with the right-hand side, substituting the number -1 for the variable t. This reads 12 minus 5 times the number -1. Well, according to order of operations, we need to do the multiplication first. 5 times -1 is -5. Now I'm going to enclose that in parentheses, not because I have an operation here, but I want to show you that the negative is attached to the 5. To finish simplifying, 12 minus -5 is the same as 12 plus 5, which is the number 17. So when substituting -1 for the variable on the left-hand side of the equation, we get the number 17. Well, let's see what happens on the right-hand side. We have 15 minus 2 times -1. Again, that's times -1. We need to perform the operation of multiplication first. So we'll have 15 minus 2 times -1 is the number -2. Simplifying, this is 15 plus 2, or 17. Since we got the same value when substituting -1 into each side of the equation, we'd say that -1 is a solution to the equation. Well, let's try another. Here we want to determine whether the given value of the variable is a solution to the linear equation. Same kind of question. The given value that we're working with is -90/7, the fraction. The equation is 1/6 a equals 2/5 a plus 3. The variable is a. Starting with the left-hand side, for a, I'm going to substitute -90/7. So I need to find 1/6 times the fraction -90/7. Now I've written it in parentheses to enclose the negative with the fraction. In order to multiply, I need to multiply numerators and denominators unless I see a factor that simplifies. And I see that 6 and 90, or -90, have at least a common factor of 3. Well, let's see. Actually, 6 and 90 have a common factor of 6. So let's simplify the common factor of 6, and 6 divided into 90 gives us the number 15. So that's actually -15. 1 times -15 is -15. Divided by 1 times 7 is 7. And -15 sevenths doesn't simplify, so let's stop simplifying the left-hand side there and move over to the right-hand side. What we need to find, substituting this value for the variable a, is 2/5 times the number -90/7, and then plus 3. Let's see. I see that 2 and 7 have no common factors, but 5 and 90 simplify. 5 goes into 90 16 times. So let's simplify that factor of, actually that's not true. 5 goes into 80 16 times. So we'll modify our simplification. 5 goes into 90 18 times. So that's an 18. Now I need to multiply 2 times -18, which is -36. I have that over 1 times 7, and I need to add 3. The common denominator for this addition is the number 7. Consider 3 to be 3 over 1 and multiply its numerator and denominator by 7. So we see that our problem is negative 36 sevenths plus 21 sevenths. We add the fractions by combining their numerators and putting the result over the common denominator 7. Negative 36 plus 21 is negative 15. And negative 15 sevenths is what we get when we substitute negative 90 sevenths into the right-hand side of the equation. Let me circle these results so that you can see we got the same value substituting negative 90 sevenths into each side of the equation. So our conclusion is that negative 90 sevenths is a solution to the equation. Let's try another. What we want to do here is determine whether the given value of the variable is a solution to the linear equation, just as before. The value of the variable we're going to use is 5. It will be substituted for the variable x. Notice that the right-hand side is the number 7. There isn't a variable for us to substitute for. So all we need to do is work on the left, put a 5 for each x on that side. Now, using order of operations, I need to do what's in the parentheses first. So I have 4 times 5 plus 3 times 5 minus 1, which is 4. Simplifying, I need to perform multiplication from left to right. So I'll start with 4 times 5, which is 20. Then I can multiply 3 times 4, which is 12. And 20 plus 12 is 32. Which does not equal the right-hand side of our equation. Whoops, I didn't mean to do that. 7. And so we conclude that 5 is not a solution to the equation. So the procedures that we've practiced are going to allow us to take a number and see whether it is a solution to an equation or actually check an answer to an equation. Now let's go into actually solving some equations. Here's what the first one that we want to do. We want to solve the equation, but then we're going to check our solution using a calculator. The equation that we see is negative 3x plus 5 equals 7x minus 15. And on page 18 in your book, you'll see the procedures that we're going to use, the addition and multiplication properties of equality. First of all, I want to put my variables together on the same side of the equation. In order to do that, I'm going to add the same amount to each side of the equation using the addition property of equality. I'm going to add 3x to each side of the equation. What happens on the left is negative 3x plus 3x add to 0, and I have that 0 plus 5, or just 5. On the right, if I combine like terms, I have 7x plus 3x, which is 10x, still minus 15. Let's use the addition property of equality again, putting the 15, or combining the 15 and the 5, by adding 15 to each side of the equation. The reason I do that, here's my equal sign, is that on the right-hand side, negative 15 plus 15 adds to 0, and so that side entirely simplifies to 10x plus 0. On the left-hand side, if I combine like terms, 5 plus 15 is 20. Now solving the equation means isolating x. This is 10 times x. To undo the 10 times x, I want to divide by 10. One way to write division is to write it as a fraction bar. So I'm going to divide each side of the equation by 10. This is actually using the multiplication property of equality. Dividing by 10 is multiplying by 1/10. But what's nice about writing things the way I have is you can see that on the right-hand side, 10 over 10 simplifies to 1x, and so that side is just 1x. On the right I have 20 divided by 10, which is the number 2. And so it looks like the solution to the equation is the number 2. What we should do is check, as we practiced earlier, putting 2 in the left-hand side, putting 2 in the right-hand side, and seeing if they result in the same answer. This time we're going to check using a calculator though. So here's the problem that we want to check. Let's start with the left-hand side. I'm going to find on my calculator -3 times 2. Remember to use the gray negative that's at the bottom of the screen. -3 times 2 plus 5. I'll push the enter button on my calculator and I see that that result is -1. I'll zoom in on the screen in just a moment, but let's check the right-hand side. We'll do 7 times 2 minus, this time, 15. This is a minus on your calculator, not a negative. Push enter and I see that that result is -1. Let me zoom in on that screen so you can see how I entered those sides of the equation. This top bit is the left-hand side. Notice that that result is -1. The bottom piece is the right-hand side. Notice that that result is -1. Let's try another problem like this. Here what we want to do is solve the equation, and then we're going to check our solution using a calculator. What we see here is 8 times g minus 3 plus 7g equals -99. To solve, we need to work in the beginning on the left-hand side and distribute an 8 to remove the parentheses. So we'll take 8 times g minus 8 times 3, which is 24. I still have plus 7g, and I still have equals -99. Now on the left-hand side, I want to combine the like terms. I have 8g plus 7g, which is 15g, still minus 24, equals -99. Now my goal when solving an equation is to isolate the variable, in this case g. So my next step is to deal with this term by adding 24 to each side. Now here's my equal sign. What's left on the left-hand side is 15g because -24 plus 24 is 0. On the right-hand side, I need to find -99 plus 24. That's a negative plus a positive. We subtract their absolute values and keep the sign of the number with the larger absolute value. So that's a -75. Finally, to isolate g, I want to divide each side of the equation by 15. I see that 15 divided by 15 is 1g, and that's equal to -75 divided by 15, which is -5. So it looks like the solution to my equation is g equal -5. Let's check that using a calculator. So I'm going to pick up my calculator and enter -5 for g. Notice that in this equation, all that's going to be required is that I enter the left-hand side and simplify and see if I can get -99, since there aren't any g's on the right-hand side. So let's see what we can do. Here we want to enter, as we see the equation, 8 parentheses -5, using the gray negative at the bottom of the screen. I entered -5. Then I have -3, close parentheses, plus 7 times -5, and I want to enter and see what result I get. I do get -99. Let me zoom in and show you how that was entered on your calculator. And that confirms that -5 is actually a solution to the equation, checking using a calculator. Well, let's try another. Again, we want to solve the equation and check the solution using a calculator. This equation reads 5 times 6 plus x minus 3 times x minus 4 equals negative 5 times 2 minus x plus 7 times x minus 4. What you might do is stop the tape right now and try this on your own and then restart it to see how you did. I'll go ahead and work by distributing, starting with the 5 at the left. 5 times 6 is 30, plus 5 times x is 5x. Now I want to distribute negative 3. Be sure to carry along this negative. Negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. There's my equal sign. Working on the right-hand side, take negative 5 times 2 to get negative 10. Negative 5 times negative x is positive 5x. Finally, I want to distribute 7. 7 times x is 7x minus 7 times 4, which is 28. Now I want to combine like terms on each side of the equation. Starting on the left-hand side, I see 5x minus 3x, which gives me 2x. And I also have the like terms 30 plus 12, which is 42. On the right-hand side, I have 5x plus 7x, which is 12x. Then negative 10 minus 28, which is the same as negative 10 plus negative 28, or negative, let's see, 38. Now I need to put my x's together on one side of the equation or the other. Let me subtract 2x from each side of the equation. All that leaves on the left-hand side is the number 42, because 2x minus 2x is 0. On the right-hand side, I have 12x minus 2x, which is 10x, and still minus 38. Now I want to add 38 to each side of the equation, which will give me on the left 80 and on the right 10x. And as a last step in solving, I'm going to divide each side of the equation by the number 10. That leaves me 1x on the right, and 80 divided by 10 is 8 on the left. And so it looks like the solution is x equal 8. Well, let's check that one with the calculator. What we need to do on our calculator is put 8 into the left-hand side and simplify, and put 8 into the right-hand side and simplify. So that's what we're going to do. Starting with the left-hand side, we'll enter 5 parentheses 6 plus 8 close parentheses. Here we are, minus 3 parentheses 8 minus 4 close parentheses. Now that's the end of the left-hand side. So we'll push enter. We get the number 58. Remember, all we're trying to do is compare the result of putting 8 in the left-hand side with the result of putting 8 in the right-hand side. So let's hang on to that 58 and enter the right-hand side. Negative 5 parentheses 2 minus 8 close parentheses plus 7 parentheses 8 minus 4 close parentheses. Push enter and we get 58. Let me zoom in and show you how I entered those. And our result of 58 by entering 8 in the left-hand side and the right-hand side confirms that 8 is a solution to the equation. Let's try another equation, this one involving fractions. Here's the one we want to solve. The equation is 3/2 t plus 3 equals negative 1/4 t plus 3/8. With fractions, you can solve the equation as we have been solving, or as an additional first step, we can multiply through by the common denominator and clear the fractions. When you look at the denominators 2, 4, and 8, the common denominator of those is 8. So I'm going to multiply every part of this equation by 8. I'll take 8 times 3 over 2t plus 8 times 3 equals 8 times negative 1 over 4t plus 8 times 3 over 8. Now this 8 that I'm multiplying by the pieces that are fractions, I'm going to consider 8 over 1. And then when I multiply the fractions, I'm going to simplify. In this case, 2 goes into 8 4 times. And multiplying the results, I'll have 4 times 3, which is 12 over 1, or 12t, plus 8 times 3, which is 24. And now, again, I want to multiply 8 over 1 times a fraction, so I'm going to simplify. 4 goes into 8 2 times. I'll take 2 times negative 1, which is negative 2t over 1, or negative 2t, plus, and in this final piece of my equation, I'll simplify 8 over 8, multiply the numerator 1 times 3 to give me 3 over 1. The point of using the common denominator is that once multiplied and simplified, we should have an equation to solve that doesn't have fractions. To solve this further, or to finish solving, I should say, I'm going to add 2t to each side of the equation. Combining like terms on the left, I'll have 14t plus 24 equals, now negative 2t plus 2t is 0, but I still have 3 on the right hand side. Now I'm going to subtract 24 from each side of the equation, and I'll continue working over here. That will leave me with 14t on the left, and 3 minus 24 is negative 21 on the right. My final step in solving for t is to divide by 14. Notice that the 14 over 14 simplifies to 1t, and on this side I have negative 21 over 14. Simplifying a common factor of 7, that reduces to negative 3/2. And so, without yet checking, it looks like the solution to our equation is negative 3/2. What we're going to do is grab a calculator and enter that in the left side as well as in the right side and see if they come out to the same results. So let's see. We want to enter 3/2 times our result, negative 3/2. When multiplying fractions on your calculator, put each fraction individually in parentheses. So if parentheses 3 divided by 2 times, and you don't necessarily need to write a time symbol or type a time symbol, parentheses negative 3 divided by 2, and then we're going to add 3 and push enter, and we get 0.75. Well, let's see if we get the same result when we enter negative 3/2 in the right hand side. We need to put the fraction negative 1/4 itself in parentheses, and then next to it in parentheses negative 3 divided by 2, and then to that we're going to add 3 divided by 8 and enter, and we get 0.75. And that confirms that negative 3/2 is a solution to the equation. Let's try another involving fractions. This equation reads 5/7 times 4d plus 1 equals 1/2 times 5d minus 5. The common denominator is the number 14. 7 and 2 are the two denominators. So I'm going to take 14 times the left-hand side and 14 times the right-hand side of my equation. Consider 14 to be 14 over 1. Now this operation right here is multiplication. I'm going to multiply 14 times 5/7 by simplifying the factor of 7 in 14 and 7, and multiplying what's left after simplifying, which is 2 times 5, or 10, over 1. And in a moment, I'll distribute that 10 through the 4d plus 1. The 14 multiplied by the whole side of the equation by multiplying by the fraction in front of the parentheses. Doing that same thing over here, I'm going to simplify a common factor of 2 in 14 and 2. Multiply 7 times 1, which is 7, over 1. And here's the equation that I need to solve. Distributing 10, I get 40d plus 10. Distributing 7, 35d minus 35. At this point, I'll subtract 35d from each side of the equation to get 5d plus 10 equals negative 35. Now the next thing I want to do is subtract 10 from each side of the equation, which will leave me 5d on the left and negative 45 on the right. Finally, I'll divide by 5 to get d, 1d, equals negative 45 divided by 5, which is negative 9. Well, let's check that negative 9 is a solution by entering it on our calculator into the left-hand side and the right-hand side of the original equation. So we're going to enter parentheses 5 divided by 7, close parentheses, open parentheses, 4 times negative 9 plus 1, close parentheses, enter, and we get negative 25. In the right-hand side, parentheses 1 divided by 2, close parentheses, open parentheses, 5 times negative 9 minus 5, close parentheses, enter, and we get negative 25. And that confirms that what we got is actually a solution to the equation. Well, in this section we've tried a number of different equations. Be sure to practice these by working some of the homework from your textbook.